So last time we had started section 2.1 and we had just one last topic that we were going to cover in 2.1 before we were finished. And that topic is actually called difference quotients. The difference quotient topic comes up in later classes of mathematics, in particular in sometimes a pre-calculus course, in a calculus course, in a business calculus course, you see it pop up again. So it's not exactly the same pieces when you get there. They go a little bit further down, sort of the bunny trail. But this is the precursor to doing that. So the difference quotient is actually taking our function evaluated at x plus h, subtracting the function evaluated at x, and then divided by h. That's what the difference quotient's definition is. So this is one of those things that's really important for future math courses, and I realize that you may not take those specific math courses, but this is a prerequisite for them. So I will ask you a question like this on a quiz, or on a test, or maybe on both. It's going to come up again. It's really important. I want you to learn there's a couple of different ways you can do this. I'm going to teach you a strategy that's called the three-step method, okay? So we're going to work with the three-step method. And the three steps are actually the three different pieces as you're working from the inside out in the difference quotient. So the first piece is to find f of x plus h. The second piece is to find the entire numerator, f of x plus h, and subtract off f of x. And then the last piece is to divide by h. So we're going to do ours in 3 steps. It's not the only way to do it, but I think it's a really nice way to break it down. So we're given that our function is 3x squared minus x plus 7. And our first step is going to be to find f of x plus h. So what we talked about last time over here is that whatever's in the parentheses, whether it's a number or a variable, and in this case we've got 2 pieces in our parentheses, we replace our variable in our equation with what's in the parentheses. So our parenthesed value here is x plus h. So what we do is that everywhere in our equation that we have an x, and there's a couple of places on the right-hand side, we're going to write x plus h. So we're going to have a 3 written, and then we're going to have x plus h squared instead of just x squared. And then we're going to have the negative, and then we're going to have x plus h instead of x, and then we're going to have our positive 7. We're replacing x with x plus h. And then we're going to do some cleanup of this algebra. Now, I want you to remember that x plus h has to be FOILed out. So I have the 3 at the beginning, and then I have x plus h times x plus h. It is not x squared plus h squared. The next part I can go ahead and distribute the negative 3 at this point. I have negative x and negative h, and my positive 7. So while it's true that you could distribute the 3 into the x plus h to start, that's a true statement, it's really not all that helpful. It's far easier to work with the x plus h times x plus h first, because it's going to come up every time you have an x squared and you're doing this process. So if I work with that and I FOIL that out, the 3 can stay put till later. I'll have x squared for my first terms. Right? My outside terms will be plus xh. My inside terms will be another xh, just so I can write them in the same order. And then my last terms will be h squared. So this will always work out in the middle to being x squared plus 2xh plus h squared. If you remember that, or you've done it enough that you have recognized that fact, jumping from here to here makes a lot of sense if you can do that. If you can't, or you're not quite to that point yet, then write it out. And then we're ready to distribute our 3 through. So I have 3x squared plus 6xh plus 3h squared. Oops, I'm sorry, I forgot the other pieces. Minus x minus h plus 7 on the end of both of them. Okay. I can't clean anything up. There's nothing that combines. Occasionally there will be, but there isn't on this one. So I'm done with step 1. Step 1 is plugging x plus h in for x and simplifying. Step 2 is to take that f plus h that I just found and subtract off f of x. So the f plus h, f of x plus h, which was 3x squared plus 6xh plus 3h squared minus x minus h plus 7 will now have subtracted the original function that I started with, 3x squared minus x plus 7. Now the reality on step 2, and this will always happen, is that everything in that subtraction piece that I just added here, I put at the end, the subtraction piece, will cancel with something previously. So you see the 3x squared here because it's being subtracted, right? The negative out inside front of here will cancel with the 3x squared here. This negative x, because it's being subtracted, would be a positive x. It will cancel with the x in the middle. And this positive 7 here will cancel with the opposite of the positive 7 or negative 7 at the end. So step 2 reduces things a lot. In fact, it reduces things so much that what we have left here is only things that have h in them. Everything else goes away, and that happens every single time. So at this point, I now have 6xh plus 3h squared minus h. That's all that remains on step 2. Is everybody good so far? Just shifting it up. Okay, that's step 2. And then step 3, if you're looking back at the expression that I wrote at the top, is that we're going to divide by h. So step 3 is to take f of x plus h minus f of x, which is what we got at the end of step 2, and divide by h. So this is 6xh plus 3h squared minus h divided by h. And this h in the denominator will always divide out. And the reason it will is because everything in the numerator will always have h's attached to them. And if they don't, it means that you have made a mistake. There's an error in previous work for you to go back and find. So if you'll remember, this is like having the 6xh over h, the 3h squared over h, and the h over h. It has to divide out of every single piece. So one of the h's has to cancel here, one of them has to cancel here, and one of them has to cancel here with a 1 now in the denominator. And this, remember, is a 1 at the end, because we're dividing. We're not subtracting or adding, we're dividing. So on the top, we are left with 6x plus 3h, because one of the h's remained because it was h squared, and minus 1. Any questions on that? So we're going to do another problem like that, because this is a detailed process. We've got 3 steps to do every time. Same directions. Our equation now looks like x squared minus x plus 3. Okay, so step 1, I'm using g, so I'll call it g of x plus h, just because my equation was called g. What do I do in step 1? Yes, put the x plus h in for all the x's. So I've got x plus h squared minus an x plus h and plus 3. Right? Excellent. Then what do? I FOIL and I simplify all that I can, or at least distribute all that I can, right? So again, if you need to see it, write it out. X plus h times x plus h. The negative over here can actually just distribute through, so I have negative x minus h. If there was a coefficient here, I didn't have one that did, but there's like a 5 here, we distribute the negative 5 through, right? Here we just have a negative. And then I have the plus 3 at the end. So if I FOIL x plus h times x plus h, I have x squared. The inner terms, xh, and the outer terms, xh, so that's 2 xh's. And then my last terms are h squared. And then minus x minus h plus 3. Can I combine anything? No. A lot of times you can't at this point, but you want to check, because if you can, it'll consolidate. You can't combine anything. So now we're ready for step two, which is to take the g of x plus h that I just did and subtract off g of x. So I've got x squared plus 2xh plus h squared minus x minus h plus 3. And I subtract off the original equation that was given to me at the beginning of the problem, which was x squared minus x plus 3. Strongly encourage you to use parentheses in these steps, right? So the parentheses up here so that you don't forget that the negative distributes through the x plus h. The parentheses down here so you don't forget that this negative is going to distribute through here. If you want to show the distribution of the negative, you can. That's fine. But the reality is that because we're subtracting everything that's here at the end, all of those pieces will then pair up with and cancel a piece previously. So the x squared subtracted at the end cancels with the x squared that we have at the beginning. The negative x subtracted, which would be a positive x at the end, will cancel with the negative x in the middle. And then the opposite of the positive 3, the negative 3 at the end, will cancel with the positive 3 previously. So step 2 is always this sort of collapsing step where we lose a lot of our values because of the subtraction. So this leaves me with 2xh plus h squared minus h. Is that all right? What's my last step? Yeah, so I take everything I just did, g of x plus h minus g of x, and I divide everything by h. So that's my 2xh plus h squared minus h. Every term has an h in it. Right, good check step there, has to, or you've made a mistake. And I divide by h. So again, each of these pieces in the numerator is being divided by h. So each of the pieces has an h eliminated when I do that. The first one eliminates the only h that's there. The second one eliminates one of the two h's. The last one eliminates the h, but please remember that leaves you with the number 1 because we are dividing. Same thing on bottom, we're dividing. Dividing by 1 is not necessary for us to keep showing, which is why we don't keep writing it. But I'm left with 2x plus h and then minus 1 at the end. Any questions on that? All right, so that ends 2.1.